Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and this video is going to focus on the general term or the nth term of an arithmetic sequence. So the formula is given on the screen as a sub n equals a sub 1 plus n minus 1 times the common difference d. A little bit about that formula. So let's write a few of these: a1, a2, a3, a4, a5, and so on. To go from the first term to the second term, that's adding one difference. So the second term has one difference. To get to the third term, that's two steps. So the third term, we're using two of those differences. The fourth term, we use three differences, and so on. So if we're looking for the nth term, we add n minus 1 of those differences to the first term. Three examples to go through using this formula. First, we're going to look for a sub 19 and a sub n for the given sequence -9, -4, 1, 6. So first thing we need to know is what is a1 and what is the difference. a1 equals -9. Now for the difference, you can subtract any two terms. So I could do -4 minus -9. I could do 1 minus -4, or I could do 6 minus 1. And they'll all equal the same thing. One of these is easier than the others. 6 minus 1 is 5. That is the common difference, but we could get it from any of those three. So if we know that a1 is -9 and d is equal to 5, we can find a sub 19. That is equal to a sub 1 plus 18 times d. And that is -9 plus 18 times 5, or -9 plus 90, which is 81. So if we kept going, if we kept adding 5, eventually we would hit 81 for the 19th term. But now we can find it a lot easier than continually adding 5. In general, a sub n, I'll write down the formula again, is a sub 1 plus n minus 1 times d. Here, that's going to be -9 plus n minus 1 times 5. And we could use this formula as well to get a sub 19. It's -9 plus 19 minus 1 times 5. We get the same exact result that we had above. So if you're doing more than one of these, it makes sense to build up the general term first and then substitute the values in for n afterwards. If you're only finding one, you can pick or choose which way you want to go. The second one, a little different spin on this. If an arithmetic sequence has terms a sub 2 equals 16 and a sub 3 equals 9, find the general term a sub n and the 12th term a sub 12. So we need to figure out first what is a sub 1 and what is the difference. And we can get the difference. The difference we can find by subtracting a sub 3 minus a sub 2. That's 9 minus 16, or -7. Now we can reason out what a sub 1 is because it's only one step in front of a sub 2. But you can think of it this way too. A sub 1 equals a sub 2. A sub 1 plus the common difference equals a sub 2. So a sub 1 plus -7 is supposed to be equal to 16. And if we add 7 to both sides of that equation, we see that a sub 1 equals 23. So now we've got our common difference in our first term. We can use this formula. A sub n equals a sub 1 plus d, n minus 1 times d. We can build that general form first, which we needed, and then we can find the 12th element of that sequence. So a sub n equals 23 plus n minus 1 times negative 7. Now, if you wanted to, you could distribute that negative 7 through and come up with a different format for, you would end up with, let's say, 30 minus 7n, and that might be easier to plug into. That part is kind of up to you. A sub 12 would be 23 plus 12 minus 1 times negative 7, or 23 plus 11 times negative 7, or 23 minus 77, or negative 54. Now again, let's expand on that idea of simplifying this formula. Right, we could write a sub n equals 23 minus 7n plus 7 by distributing the negative 7. And simplifying this, you could get 30 minus 7n by combining the like terms. And so when we go to do a sub 12, we would have 30 minus 7 times 12, which would eventually get us back to negative 54. So if you like the look of the second one, use that one. Right. One last one to go. We're told that a sub 9 is 22, a sub 15 is 76, and we just want to find a sub 1. So this is part of what we did in the last one. First, from a sub 9 to a sub 15, that is 6 differences away. So we know that 6 times the common difference would be 76 minus 22, or 6d equals 54, or d equals 9. Then we know that a sub 1, we know that a sub 9 would equal a sub 1 plus 9 minus 1 times the common difference. So we know a sub 9 is 22. We're looking to figure out a sub 1. 9 minus 1 is 8, and d is 9. So we would have 22 equals a sub 1 plus 72. Subtract over the 72, and we find that a sub 1 is equal to 50. Now notice in the second problem we did, which is labeled as problem 3, we had 2 terms in a row, so we didn't really have to worry about dividing to find the common difference. But if you have 2 members of the sequence that aren't next to each other, you do have to divide by how many steps apart they are. All right, that's it for this one. In the next one, we'll come back and we'll take a look at series involving arithmetic sequences.